Yeah, let's start this session. So are you guys able to access the data set using the college ID? Yeah, hello. Yeah.
Which data sets? This is the.
Okay, just yeah, few of you just stimulate. I just said in the chat box. Okay, I'll just paste it again. Just access the collab using your college ID. In the meantime, I'll just. Actually, this is two different files. Yeah, just I converted in the array format, and yeah, I'm sharing that actually. One would be your features data, and one will be your target data. Directly I can save this folder.
So there are only one file, right? Faces.npy.
Faces.npy and one more link I sent. No, like.
Oh, okay. There are two links. Faces target.npy.
Yeah, so just load those both data set in collab, and yeah, once we all are at same point, yeah, then we'll start this. So how is the week 7? Yeah, how is the week 7 going? Whoever has already uploaded their data set, they can answer. I think. Just to load this one, just use, since it's a numpy data, just use this one, np.load. Just import numpy as np, and you can use this one. I think, yeah, many of you will be struggling to load this one. Are you done? Are all of you done with the opened a collab notebook, and yeah, just mounted your drive?
Yeah, see, can you just go through this files upload? I don't think people have done it. I also was trying to do that. That is simpler. So
this one.
Yeah, because previously we have been talked about putting it in collab and then using open to read it from collab.
Okay, yeah. You just do this one only. No issues. Just from google.collab import files. So yeah, upload this. Both of them. The thing is, it gets uploaded in your drive only. Like it is kept here at this part. Okay, and if you have uploaded in your drive, then it would be inside your drive. Yeah, under this folder, drive, content, at this one. Yeah, my drive. Okay, in this one, yeah, this is your data set. Here, whatever we are talking. In that case, you had to use the, but the thing is here, it is a numpy file, no? So to load that one, you have to use this one, not pd.res, pd.read CSV. It won't work. Yeah. Just load both data, like, yeah, in the pics, keep name as, yeah, pics for np.load face npy file, and yeah, target. You can give the two different names to load both data.
So this seems faster than the putting it in collab ourselves. Okay. So
Yeah. It's okay. You can try. Whatever works. You can.
And anyway, sir, I'm using your trick of using PyForest. So
Yeah.
most things, some perceptron it didn't work, but I'll check it. But linear regression, the graded assignment question 1 to 3, I didn't have to load anything.
Okay.
Load anything, it just automatically happened.
Yeah. Most of the famous data, yeah, library does saved that. So how many of you will code with me today? Like, because in the last session also very few people were talking. Yeah. Just type something in chat box so that I can understand, and I will wait for the people's answer. Yeah, apart from Srinivasan sir and Rajiv, yeah. Hi Arsad, what about you? Arsad, Gautam, Nikite, Mihika, yeah. Gayatri, Manav, Mukesh, Rishabh. I think this is using two IDs. Or I just saw. Yeah. Yeah, we got. Yeah, Mukesh is also. Okay, are you guys done with this part?
Yes.
Still loading.
Yeah. Okay. Still, it takes time.
Yeah, 400 images are there.
Yeah. Get to know. So yeah, you can see, you can watch the video on YouTube also. Manav will also code with us. So whoever is loaded, he can answer these questions right now.
40 labels. Huh?
Yeah, 40 levels. Okay. So the thing is, just think it as a question. Just think frame a question in your mind. Like, yeah, you came in your new company and you are seeing just so many new faces there. So what you plan is, like, sometimes it's very disrespectful to address a person by his name. So you are planning to make a model which will help you to identify all new colleagues name by their photograph, just by seeing their photographs. Okay. So for that, you can do many things. I was just trying to frame this question. Yeah, like in last 5-10 minutes only. So, but yeah, you can think any application for this, like face recognition, like some are there like a attendance system. In those cases, we use this face recognition system. Okay. So yeah, someone can give some new application, or can someone tell about some other application where we can use this one, face recognition? So face recognition is nothing but identifying and verifying people in a photograph by seeing their face. So obviously it's a very small model you will do today, but yeah, many application, and by adding many new features we can use this one. So can someone say some new application, like where you will use this? Just think like you are going to build a model like which will identify people by seeing their photograph. So where you can use this one.
Nowadays, these are using also in your that automated card. So
Yes,
car will move, they will detect whether it is a tree, whether it is going in lane or not. So
right. Many new applications are there. Yeah, so yeah, like that only. Just some other people can also say some other some other application. Like seeing the signals, like whether it's some like as Tesla is making, whether when see the vehicle will see exactly that whether it's a red light or green light. So yeah, fakes. Yeah, that one is also like you have just given the input of few faces. Identification of criminals. Yeah, that one is also a good one. So yeah, when I was working in college, one of my friend has got an internship. Got an internship where he was working on a project with Assam Rifles. They were planning to make a ML model which will be implemented on their main gate. So yeah, by seeing their movement and faces, they used to allow the gate whether it will open or not, something like that. So I think now can we proceed further? Hello.
yes, I think yes.
Yeah. So yeah, as the data you would have seen in the data set, there are 40 different subjects, or you can say think about the 40 different peoples are there, and they are like each people's 10 faces are there, like 10 pictures of each people are there, like in different context, in different with different expressions. And you have to just think like this target vector is like a name, like already here we have mentioned like 0 1 2 3 something like that number we are providing. Just think it like the name of that person, like that is your target vector. So you in this model you will just see, you will think it like you got some pictures and you have to predict who is this person, like what is the name of this person. So here the target is like 1 2 3. So think it like this person's name is person 1, something like that. Okay, so that is the image credit goes to AT&T Laboratory Cambridge. So these pictures were taken around 1977. So from there only like we imported this picture and we just converted into ND arrays. Okay, so I think so. Should we go with the code or just here we can just okay, we'll just see this step by step only. So in the step 2, just take the so I think all of you are done with the step 1. Okay, in the step 2 you can check the shape of your data set. So what is the shape of your data set you are getting? And once again I will ask, so everyone is able to load their code, no? Load the data on the collab, no? Is anyone left? I think okay, so what is the shape of the data set? You can comment. So I know like everyone will just you have to type just dot shape, but at least I will got to know, like I will get to know that who all are working with me. So you can type this. Okay. I'm not. Yeah, you can. Whoever is, they can answer in the chat box only. Like, yeah, they can send a personal message, or yeah, that, or yeah, they can speak also. That would also work. Okay. So can you guys plot the first 10 images? Yeah. Can you guys plot a first 40 images? Hello, at least tell your doubt, like where you are lagging. At least then I can
Yes,
help.
yes, we are trying. We are trying.
Okay, yeah, that will be good. Just to load this and numpy data, yeah, we can use the code np.load. Yeah, then to check the shape, yeah, you can type the pix.shape. It will give you the shape of your data set. Yes, so yeah, up to 40, yeah. Yeah, like this, yeah, like this, you will get the data say the yeah, whatever the code you have written, using this one, you want to be able to plot the figure. Yeah, you will get the data of the first 40 peoples. That's true. Yeah, this one, this code is correct.
You want to show the image?
Yeah.
Okay, okay, okay.
Okay. So yeah, here we saved the labels also. Just see the label. What is so just by seeing this labels, what you are able to understand? Can someone comment? Any idea which you are getting? Like the thing is here is like first 10 images belongs to same class. Like have got the same level. It means the first 10 images of same people. If they are different faces and all, yeah, whatever is the case. But yeah, this is that we can interpret from this one. Like yeah, first 10 levels are same. So yeah, first 10, since the each level is representing the one people, so one people's name. So yeah, first 10 people, first 10 images of same people, or yeah, belongs to same level. That we can think from here. Okay, let's see. So what we will do here is, yeah, we will just plot a figure. Just we will put this one as the figure size. We have given here as like a 20 cross 10. Okay, just set columns equals 8 or row is equal 5, whatever you like. Since 40 pictures are there, so we are planning to print one photo of each employee. Okay, or you can, I think we should write colleagues. That would be a better, since we are talking about your colleagues only. So yeah. Okay, so what we are doing here is like, yeah, we are planning to we are planning to plot picture of each of your colleagues. Since we saw, so what we put here, we are setting columns equal to 8, row equal 5, so that we can plot 8 people's pictures in one rows, and five pictures, 5 people's picture in first column. Okay, so like that. So okay, let's see. So for that, what we are using is like our range should be since as we talked, like there are 400 images. Okay, so you have to print like every 11th image is your every 11th image is your new image. Okay, like that we see. So if we have to plot the image of all the 40 people, so we have to print the 0th image, 1th image, means index image which is at index 0, then image which is at index 11, image which is at index 21, image at index 31, something like that. Okay, so that we will get the every image as a unique image. Okay, otherwise any image if we will take from index 0 to index 10, that will be the same image. Okay, so are you getting what I am saying, or I talked something alien? Hello? What I am saying is, just think it like, okay, we'll just plot the first 10 images, something like that we will call. Okay, so the thing is, here we are doing as we are setting it as a 10 cross I minus 1. Okay, so we can set it as from 1 to 40. Okay, nothing, this one. Yes, so just plot this one. Okay, so we set this column and rows, just these 3 lines are representing like how what is the shape of our image, whole image that it is showing. This code is for that. Then for I in range 1,40, so we will take I values, and this one is just add subplot. Okay, and color, different colors we can put. Here we have put we have used this gray color. Okay, just use this one, default one. Okay, don't put any color. Okay, this is the code for filter.getC map. Okay, and this one is to just write the title, and since we don't need that axis like x y axis kind of thing, so we just use this one, plt.axis off. This one we use to just write the give a title. Okay, or just to make the code easier, just remove all these things. Okay, I think since none of you are responding, so I am also thinking like just see here. Okay, or just let me just make it as a 10 cross, because all the 10 images belong to the same people, no? Okay, 10 cross 40 images we are plotting, so 10, 4 rows are enough. Okay, and we will put the color also gray, because otherwise we are not able to interpret it. Okay, spelling is wrong. I think let him check what is the spelling. Here. Let's check this one. Or if you want, I can remove this part also. Like let it plot whatever shape it wants, or it's okay. I think 5, 6, 7, 8, 9, 10 is so I think so you are able to see this one, like all these first 10 images belong to the same person. Okay. Hello.
Yes, yes, we are able to plot. At least I am able to plot now.
Yeah. So some other people also, they still are you able to follow me, or I should discuss the yeah, I think I just discussed all the lines of the code.
So how, okay, just a curious thing is that, was it able to fit this much in that small shape, 64 by 64?
Yeah, that's a Greek color image, no? That's why it is able to, and we have converted it in yeah, NumPy format, so it is a bit faster, and it is taking less space.
Yeah, but even the original shape was only 64 by 64 matrix. That was
Yeah,
the
yeah, yeah,
original shape, yeah.
Yeah. So yeah, we are able to see that every 10 images are belongs to the same person. Okay, like different expressions and lightings are there. Yeah, but yeah, like that. So yeah, so what we have to do is, like, we are trying to plot the every image as a unique image. Okay, so what we will do is, like, we will plot the first image, 11th image, 21st image, 31st image, so that we will get the all the unique images. So first image, 11th image, okay, then 21st image, 31st image, like that, so that we will get every image as unique image. Okay, like I think it is 10 only. Okay, yeah, I got what mistake we did, and why we are getting pictures. Okay. So we have this one, no? So it is not working for this one code. Okay. Yeah, all the images belong to the same person. 8 to 5, 7, 9. Okay, so I was thinking, like, first 10 images belong to the same person, but it looks first 9 images belong to the same person. 3 to 5, 7 to 9. Okay, and that's why I was thinking, like, this image should be here, or why we are getting like this. Okay, we'll see, we can see that later. Okay, so what we will do here is, we will plot all the every image is a unique image of an employee. Okay, so the same code, but the new thing is in this line. Okay, so what we are doing, writing what is unique about this line is, we are just multiplying 10 cross I minus 1. Okay, so what we are doing is, when we will set this I equals 1, when I is 1, no, this is the first, this is image as like I minus 1, so 1 minus 1 0, 10 cross 0 0. So it is plotting the 0th index image. Okay, and then it is plotting as a, when we are putting I equals 1, so then 1 for 1 it was there, so for 2 minus 1 1, 10 into 1, so it is plotting the 10 image at the 10th index. Okay, like that we are plotting, and like that this code will work, like 0th index, 10th index, 20th index, 30th index, like that. Okay, so just try this one. Okay, nothing new, just just change the in that code only, previous code only, like for where we had written just I, just write this one in star I minus 1, so that we can get the image after 10th iteration. Okay, so that mistake I was getting here, or we can write here also one thing. Yeah, now we are able to see, like, each row is representing us like same person. So is everyone got this image? I was just trying to show that like what are the different people, what is the image of the different people. So nothing new, and it has nothing to do with our codes, like yeah, our modeling part. But yeah, just to visualization part by this. And you can try with the different colors, like default digit, spectral. So this one, yeah, now we got this. All the taste news is in the same line. So yeah, so same person without goggles also is there in this image data set. Okay. Yeah. So are you guys got this? All the images, all the 40 images of unique people. Hello.
Yes, I am able to plot.
Yeah, some other person. Raji, what about you? Srinivasan sir, Manav.
No, I'm able to get some images, but I'm not able to get all the images. But I think there's a small error in my loop, but I'll fix it.
Yeah. Okay. Just can you show your code, or so that yeah, we all will move together.
No, I did the first part, the same images. I'm not getting the second one, but that's okay. That's fine. So
okay, yeah. Then in the first
it'll be just a small loop. Because I'm using a different size plot,
okay,
so that I don't copy your code again.
yeah. Don't copy.
Maybe a small mistake.
Yeah.
I can debug it later.
Yeah. Okay. And yeah. So Raji, what about you and Manav? So like that, you can save the image of all your colleagues. Yeah, you just try. No issues. Just focus on these 3 lines. Okay, these 3 lines are enough. Yeah, these 4 lines actually. Just plot these 4 lines, nothing more. And yeah, and because yeah, these things are just new, and all other things are just same. Whatever you guys were doing in your old data sets only. Like just import that, just do the trace split part. So because I think you should do this part, like you should follow the other steps. Like yeah, just do the test split part. Shape, yeah, just check the shape, and yeah, use the logistic regression model. Okay, at least just do that test split part by that time. Yeah, and sorry if Manav, yeah, you can write this. Yeah, these 4-5 lines. Anyway, just try to plot this one. Okay, later we will share these codes, so yeah, you can try later also. Some bigger things if you are missing. Okay, let's move to the next part. Okay, so what we are doing here is, yeah, we are just now we saw that what is the data we have. Okay, now just let's come to the real part, like yeah, our modeling part. Okay, so we save all the data of pixel in x variable. Okay, and yeah, all the y data in the y variable, all the labels data on the y variable. So no need to do this reshape because it's already in this shape only. Okay, so that's not an issue. Okay, yeah. So after that, as usually whatever we used to do, like yeah, just import this trend test split part, and yeah, just split the data. Okay. No need to do these things. Okay. Just write these 2 lines. That's enough. And not even the first line also. If you have imported the PyForest library, this first line is also not needed. So just this line. Okay, I'll just to check this if you can directly write these things. Just .shape. Yeah, this much is enough to get the answer. Yeah. So are you all able to do this part? This string test split part?
Is that done? Yeah.
Yeah. One person. Manav, Mukesh. Yeah, Rajiv. I think Rajiv is not responding. So yeah, Srinivasan sir is able to do that. Yeah. What about you, Mukesh? Are you done? Actually, these images are from some laboratory of Cambridge here. Yeah. There only we got all those images. So okay, let's move to the next part. So yeah, why we did this? Like why they just received our data set or the shape in this format? Like yeah, in this format, because we have to use those to plot the images. Okay, like
So one.
Yeah, please. Hello.
X is still in the same shape, right? It's a 3-dimensional thing. We are not changing that shape.
This one, no? Yeah, but our model doesn't take this 3x3, these three.
Because we are doing neighborhoods, we don't need to label that.
Yeah. So it takes like a feature and sample, number of samples, features, and target. Okay. So we have to make that in such a manner, in that shape only. I mean, we have to flatten that area, no? Are you getting whatever I'm saying? So in every image data set, what you have, let me come to that example.
Yeah, so did we flatten it? Okay, you have flattened it. No?
Yeah. We have to flatten it. Yeah, in the future, next step, we will do that. Like the 8x8, 64x64 was there, no? So we have to make it as a something cross 1 in that shape. Yes, so I think, yeah. See. So this is this is the shape of our current data set, no?
Yes.
Okay. So no issues. The thing is, what it is representing? It is representing we have 320 samples, and each sample, each sample shape of each sample is 64x64. It is like that. Are you guys ready? Are you guys agree with me? Yeah. Okay. So, but our model, how it works is like it will think as we have 320. Say 320 samples, and we have to features in the we always take all the features in one row only, no? Like, yeah, feature 1, feature 2, feature 3, something like that. I mean, if we will make this 64 cos 64, we will bring all these. Let me just use some visualization. Okay, I'll open. I'm just opening the notepad. Okay, there we can. So notepad is visible. I think it won't be visible. Yeah, I'll stop sharing screen and. So whether my screen is visible or not?
It says started screen sharing, but I don't see any. We don't see any.
Okay.
But that's a simple thing, sir. We could do the reshape before the train test split also, right? There is no reason to do it after the.
Yeah. We can do it. Yeah. No. Nothing like that. It is just that I was talking like what we receive, why we are doing reshape.
Okay.
So I was trying to explain that part. Okay. No, I was not saying that. Yeah, we have to do this after that. Split
that
only.
we did it for n-digit, even the digit database. We always reshaped it because we want to have that many features, right? Because we can't have a matrix of features. We want them to be a single column. Yeah.
Hello. Hello.
Yeah, we can hear you.
Yeah, I think lost connection.
Yeah.
For a few minutes. Yeah. So sir, Srinasan sir, you were saying something. I think I was not able to hear you.
No, I was just posted my code. I just did reshape and shape 0 and then -1. So that also will work, right? You don't need to specifically give the second and third arguments.
Yeah, exactly.
I put it in the chat. I don't know whether you saw it. Okay, let me put it again.
Yeah, I won't be able to see that chat, but it's okay. You are able to reshape it in something like in this fashion only, like sample into features. Yeah, htc.reshape 0,1. Yeah, that will work because you have kept at first place the number of samples, and you allowed your data set to to put the number of features automatically. Yeah, that will work. Okay, let me ask. Okay, I need to ask the host to make me co-host again so that I can share my screen. So whoever has done that part, they can move to the next part. Like they can train the logistic regression model on that data set. Okay. In the meantime, I will ask host to make me co-host again.
Also waiting because the instructions, we need to know the right instructions for the logistic. So we'll wait till you share that screen. Yeah, that's
Yeah, okay,
instructions
okay.
again, steps.
Yeah, no issues. Just I was asking. Nothing new you have to do. Just think it like just think, not just think like yeah, you have something number of samples, you have some number of features. That's it. Okay. Now you have extend. Okay, I will share the screen, but in the meantime, yeah, just try. It's just a 3 to 4 step process. Okay. Yeah, still he hasn't shared that.
Okay, sir. What was the parameters for the logistic regression? Can you just mention it orally?
Parameters for logistic regression. Okay. Yes, for logistic regression, you have to put something like nothing, no parameter, just without any parameter, just train your model. Okay, don't give anything. For in the next step we can we will do that. Yeah, we will put multi-class size, multi-linear. Yeah, using softmax regression. But yeah, for first case, just put don't give any parameters. Okay, just simply just import logistic regression and use that logistic regression dot fit. Okay, just do that. Hello. Yeah, now I'm close to, I'll share my screen. Nothing new in this sentence, just I'll just write the simple version. Okay. No need to put anything something like that. Just these 3 lines are enough.
I get a convergence error. So
where you got the conversion error?
oh, I didn't put max iter equal to 1000. Okay, let me put max iter.
Okay. Yeah, max iter. Okay, I just didn't receive our training data set. Let me receive this one. I just trained this out. Yeah, just model accuracy. Yeah, these 3 lines are enough to get the model accuracy. Okay.
Format is not finishing. It's running for a long time.
Yeah. That's why I just intentionally I use this logistic regression. Okay, because I just wanted to show you see you that comparison. Okay, like how much for just for 400 samples it is taking this much time. Okay, because we have 4096 number of features. Actually 320, just take it as 320 samples we have. For that it is taking this much time. Okay, but you will be able to see that like how much time it takes for this one. For Canon for Canon classifier. Yeah, this line is much simple, much more. Yeah.
So I had to stop it. It went for 1 minute. It did not finish for me.
Yeah, it takes a longer time. Yeah,
Okay.
right now. Yeah, it takes around 1.5 minutes. I think somewhere near to that. See, because they see like 4096 number of features you have, so it will take enough time. Or yeah, we can move further also if all of you are able to do up to this much. So we will move further. So can you say like what that adds accuracy of your model? And what we have done here is we just rounded it to up to 2 digits, and we converted it into the percentage. That is what we did here. Nothing new. I think we should move further because 3 questions are there, and I think one question is taking so much time. Yeah, actually, it is supposed to take this much time at least. If hello. Hello.
Yes, sir. I'm here. I'm just waiting for my code to finish.
Yeah. Okay. So it's okay. Just bring that Canon part. Okay. Don't do on this one. Just do that. We can speak. Later you can do. You can try it with the softmax regression. Okay. Just bring this one. Okay. Just import this Canon classifier, or just simply write the Canon.fit extend ytran. Okay. This one.
And neighbor equal to 1. Just one neighbor.
Oh no. I have written this one here. Okay, but later we have checked with a different number of neighbors. Okay, so we have checked that, but where it is? Okay, here it is written when we have kept the neighbor equals 1. Okay, so I think there was a code like where we used this grid search to check all the neighbors. Okay, you just put it neighbor as a 4, or actually we have got the better result for neighbor equals 9. Okay, just I don't remember actually. Yeah, so obviously you have to change all the neighbors. Like just write like here only like for k in, or something like for I in k range 1 to 40, and just change all the neighbors value. Okay, well in the second question we will do that. No issues. Here we have kept the neighbor equals 1. Just fix 1. Just because I also want to just move a bit faster, because just change it. Just put it with 5. Okay. The neighbor equals 1 give the best result for this data. Okay. Is it? I also need to check. I think it looks I had checked. That's one. Okay, let's delete this one. So what we did is like we created this one. Logistic. We trained our model on logistic regression, and we got the accuracy around 96.25. And then in this one, we just trained our model using softmax regression, and we got our accuracy around 96.25%. Okay. So in the and here for in the question only it was mentioned like we have to calculate F1 scores also using this one, using softmax regression. So we calculated that part also. So these things are pretty simple actually. The old code which you have just paste it and you will get the answer. Okay, nothing new in this part, but still, yeah, I expected you people to do this one. And I think this one I have trained the model. Later I just move the code. I would have formatted for that also, like, yeah. I would have, yeah, using this one grid sets also, like we can do that, but yeah, it's better to use this one only. So are you guys following me or I am doing something?
No, sir, the last part you went. So can you just give us just the last instruction? K neighbors with 5 classes, 5 as neighbors, right? We have to train the model and fit.
Okay, yeah. This one only, no?
Okay, if we can just stay here, sir, we'll just finish.
Yeah, just do that. Yeah, we get the best result for K neighbors.
I got 92.5, yeah.
Yeah, for neighbors equal to 1 only. Yeah, 92.5% with number of neighbors equals to 1. So I think, yeah, all of you are here up to here.
Yeah.
Hello?
So
Yeah.
one quick question. So you
Yes.
called it accuracy. So the score typically gives the root mean square error, right?
A root mean square in case of regression.
Okay, in terms of classifier, it will directly give the accuracy
of true positive plus true negative upon true positive plus true negative, something like that. That confusion matrix. Remember?
Yeah, I know, but the accuracy, I
Yes.
didn't know that accuracy comes directly from the score because I used to print the matrix and then calculate the accuracy.
No. We get that from that. What you say? This one only. Like, yeah, from the score we get that accuracy only. Okay. Or we can just plot. We can see that one also. Dot confusion matrix. We can write that code also, like to import that sklearn dot matrix confusion matrix. Import confusion matrix, and yeah, after that we can check. You can just check that you will get the same accuracy only. Like that, it is that accuracy only. Like when we use this this accuracy, that it is same, that whatever accuracy we get using that confusion matrix, true positive plus true negative upon all other values. So yeah, this one I think you are able to do this one. Okay, so what we did here is we just created a data frame using that method, and which method give what accuracy. Okay, you can do that later whenever you will do this code from your side. You can do make a table So to do this one, yeah, what we did, like we created two empty list, and yeah, we all the results just we appended in those lists. All the results, yeah, we appended in that list. Just two extra lines after every code. Yeah, after using every estimator, you can use, yeah, something estimator list dot append, yeah, that model name, yeah, estimate accuracy list dot append that model accuracy. Okay, using this you can just,
Okay, so for the various models, okay, one by one.
yeah. So at the same place you will get as all the results you got in a table format, something like that. Okay, or we can use that. If you want, you can make one more column like for F1 score, and yeah, recall scores, all the scores. Yeah, you can plot in the same table like that. Also, you can do. Okay, so just to check that, I just intentionally just gave the question. Yeah, just calculate F1 score for softmax. Obviously, you can calculate for all the metrics. Yeah, for all the estimators, but just for the sake of questions, I just gave that. Yeah, what is the accuracy you got? Yeah, what is the F1 score you got with softmax regression? So yeah, now I think, yeah, we all are able to got all the 8 answers. Like, what is the shape of your data set? How many labels are there in the data set? How many examples are there with each class? What is the shape of X-train and Y-train? Convert X-train and X-test shape into A comma B type. And what is the accuracy you got with the logistic regression and Cannon classification? What is the F1 score you got with softmax regression? Okay. Yeah. Yeah, using this confusion matrix also, like you can check the accuracy of your model. Okay, do one thing. Yeah, you can check the accuracy of our model using that one, that code also. Yeah, just like this one only, the same syntax. So just here we use the F1 score. You can write that accuracy. You will get the answer. The same answer you will get. Okay. Let me try this one. Although we haven't imported this one, let's.
But the confusion matrix will be a pretty.
Yeah, all the results are at the same place. It is like that, no?
No, but it's also because there are lots of features, right? So it is a huge.
Yeah. That's also true. Confusion matrix is not a good way to plot here. In this case, particularly. Have we written some wrong spelling? Okay, we didn't imported this accuracy. Okay, we have to import this. Okay, let's still just. Yeah, this one is we have written as a wrong. Okay. Yeah, whatever is the syntax of that accuracy, no, we imported that. Just check this one. What is the syntax for this? Okay, so it is like accuracy score. I think that soon. I think yeah, we will be able to do this one. Okay. I think I'm. So I think yeah, this one is again got it. Okay, average is not there. Yes. Yeah, I think we are able to do this. It's just about importing, and yeah, we will get the same result. We are able to see that yeah, 0.9625, whatever is the accuracy we got using that one. No. Hello. Hello.
Yeah.
Yeah. This is the same one only. Okay, so I need to do this one. Okay. Yeah, let's move. Yeah, and do you know like how much k value we try our model for? How much k values in general?
1 to 10 is what is being shown in the demo, not more than that.
Yeah, but in general we try our model using square root of that number of samples. It's a good practice. Like yeah, people usually do like that only, like square root of that number of samples.
Okay, but here since we did not shuffle the data, right? I'm surprised even the neighbors equal to 1 did not give a higher score because all of them are neighbors, no? Because
exactly.
Yeah, given 100% score actually.
You got the exact reason actually. Whatever you said, no, that is the exact reason why we are getting this much. Yeah, we are getting the best score for a number of neighbors equal to 1. That is the main reason, because all the correct photos are closer to each other, no? So that's why. So obviously those things, whatever you are, I was trying to show this one, and yeah, you can use that shuffle equals true and all. You will get the better result, and more accurate result, or whatever is a more robust model actually. Okay, so yeah, those things we can try. Okay, so
just a question. So you are using functions like accuracy score, F1 score, score now. Okay, all of them exist. Okay, we don't have to.
Yeah. All of them are there, like F1 score, accuracy score, all of these things are there. All the precision recall, all the things are there. Okay.
Yeah, because I used to get it as a full from the report. I used to pick it up, but I didn't know that.
Yeah. Yeah. So as you said only, like here we have this much, around the number of features in thousands. So if we will do that like that, just think what will be the shape of our confusion. Confusion matrix will be correct, but yeah, that classification report, how much long it will be. So yeah, you can calculate using this one, like directly F1 score, accuracy, precision. That's right. So yeah, you can train your model using grid search. You can use grid search also to tune your hyperparameter K. And yeah, you got this matrix. And yeah, second question. So Ken regressor. So are you guys planning to do this question along with me, or should I just demonstrate that? Because I think yeah, we have just 45 minutes. So what you guys say? Okay, I'll just you
I'm
guys.
ready to do it along with you, but if you want, you can demonstrate also. Either way is fine.
I am also ready with both the cases, in both the cases, because yeah, whatever the majority will say, I'll do that only. Because yeah, that is it is a better practice. Like I know, like very few of you will do this code like after this SWI session. So that's why I'm saying. And yeah, I also got to know, like yeah, just first, if I'll cover properly, then I think yeah, first question only will take the whole 2 hours. Because if you just think like yeah, if you will use all the grid search and shuffling and all, cross validation and all these things. Yeah, it will take enough time. Okay, I just shared the second data set. Okay, just you guys can try this one. This one is pretty simple. Actually, yeah, we have lesser number of features. It will also take lesser time to train your model. Okay. So I think everyone is, who all are just coding, like who all are coding, or just is it just Srinivasan sir or some other people are also coding along with the session?
I'm coding, but the loading takes time, so I'm just waiting for the loading to finish.
Okay, no, yeah, because very less participation I'm able to see. Yeah, attendance is good, but it is still looking like MLF session only, like only you are talking. This time in MLF, people are really, they are taking participation in the session, and yeah, more than 150 attendance we are getting. Like I just, so yeah, you can, in the meantime, I will talk about this data set. Yeah, so we know that, yeah, insurance company has been variously described as laggard, sloth-like, and conservative in its responses. But data science like you will help them in making the best use of new age technologies to constantly innovate, revamp up customer satisfaction, and stay ahead in the race. Okay, so to do that, there are many aspects in which yeah, ML model can help to, yeah, to reduce the time. So yeah, in this model we will do this one, like we will predict the future medical expenses of a individual person based on just by seeing their body mass index, their sex, age, and yeah, whether he is a smoker or not, and yeah, from which region he belongs to. So you just seeing this data, yeah, will predict like how many future expenses he will do on the medical. Yeah. So yeah, based on that, it will help the insurance company to, yeah, to charge to make decision regarding like how much premium they should charge with that particular person. Okay. So yeah, this data will come from like, yeah, there's website like where people will fill all their, yeah, data like what is his age, all these things. Yeah, and based on that, yeah, they can predict. So you have to create a model which will predict the yeah, future medical expenses. Okay.
So I'm getting error in reading the file pd.load, np.load.
No, this one is data framed. You can type the pd.read CSV. Okay. Hello.
Data frame. I can't use np.load.
No. That was because the earlier file was numpy file. Okay. That was in the array format.
So this one, how do I load it? After I uploading it, how do I open it?
pd.read CSV. Use code pd.read CSV. It's a CSV file. That one was actually those type of question. What the thing is, you will get in zip file, and in that zip file you would have, yeah, two data sets and all this. Yeah, it would be combined only, like, or we can also do that, like we can, but there were many steps which I skipped, like to extract the files from that zip folder, and yeah, again to use load that. Yeah, all those things we skipped.
Okay, so 1338 samples, right?
Yeah. Okay, 1338
samples.
Yeah. Yeah, 1338 samples. So yeah, what are the steps? Yeah, you can say like what are the steps you will follow. from your side. Just think like you got the data and you have to predict the premium of the future expenses, medical expenses. Okay, so what steps you will follow? Just you can say, and I will just correct. Like
First is, of course, we decide this is a regression problem. Right?
Yes. First we will decide. This
But
is regression.
going by the suggested approach, first you look at the number of features, the shape of the type of the features, and all that stuff. So you get that part, right? And you also know this is a data frame, so the label will also be right there in the feature. Typically, the last column is the label, but you have to ensure that the number of output, right, whether it's a single output or multi-output regression. But here it's a single output regression, seems to be that way. Then split the data, train and test, right? And then apply the regression model, right? Obviously, you have to apply at least SGD, if not anything else.
Exactly.
And then go from there.
So all the steps are correct, but the steps which take the maximum time, that is the pre-processing part. You missed that.
Sorry. Okay, sorry. So after you split it, you look at what model to apply, right? What are the various features, what scales they are, and see whether they need to be scaled. So obviously SGD, you will have to scale them because there is age, body mass. Obviously, there are different scales, so you have to scale them to standard scaler.
Exactly. Okay, so let's start with the working on this data set. We just see like all the infos here. We just check the two things. Okay, in the info part, we check that how many non-null type are there. Like we are able to see that all the, like we have 1338 samples, and in all the cases it is the like non-null type is there. All are equal to 1338 only. So no need to think about so we can, from here also we can say that we don't have any null values. Okay, so we can move further, and just by seeing this one we can we get some idea just by seeing this one?
There needs to be scaling because they're very, very different.
That needs to be scaled, because that is the one thing, correct?
Mean itself is very different, right? So
this one is very important. We are able to see that the mean is around, age is around, average people's age around 40 years, body mass index around 30. So all of them are overweight. Most of them are overweight. We can say around 18 to 22 is the ideal body mass index, no, sir?
18 to 22, it depends on, it changes, but if this is US, there is a lot of obesity problem in the US. So
okay. You
might not find many adults below, unless they are fit adults. The average adult may be much over 22.
Okay. Yeah.
So, I used to have this, I actually have the picture also. So in Japan, you go to a lift, they say 10 people and they say 640 kgs or 700 kg maximum.
Okay.
So US, if you put a lift for 10 people, you have to put easily 2,000 pounds or 100,000 kgs, or because that's typically will be the average weight.
So body mass index around it. I think for ideal people, we calculate body mass index seeing this height and weight, no? Seeing the height and weight, we calculate that body mass index, and ideal range is for healthy people, it is around 18 to 22, I think.
So 20 to 24, but there's also a difference at 20 to 24. There could be slightly people who are heavily built, maybe till 24. Typically, about 25 is considered starting getting, on the unhealthy category.
Yes. So that is the expenses. Average expenses of people are around 13,000. 13,270. Okay, so these things are very important. So now we will check some categorical variables, like how many different values are there. Like we just check as a sex, as a male and female. Obviously, we were expecting two type of value, two levels in this column. Okay, so same in case of smoker, whether people will be a smoker or he won't be a smoker. Okay, like that. So yeah, these two things are there. So now we will check this. Is there any duplicate data? So yeah, here we saw that yeah, one column, one row we got as a duplicate data, like which is a copy of some other column or some other row. Okay. So what we will do is like yeah, we drop that row. Okay. And since we have used this n place equals true, so it would change in your original data set. Okay. So that
how did you just do data duplicated? Just straight away it gives you duplicated data?
which one? Sorry. Yeah, it will give you if you will write the data dot duplicated, it will give you the Boolean value. Okay. Just see this one. I didn't train actually. Then I have to just load all the things. Okay. If you will click this one data dot duplicated, it will give you the Boolean value. Okay. So to get exact that value, you have to just write this one. Okay. What we does is like when we put this one, then it gives the value when it is true. It results that value when it is true. Okay.
The
Like
index
that.
is starting from 0, right? So I can just
Yes.
drop that 581 row.
Yes. That you can do also. Yeah. That you can do directly using that index. Okay. And here, yeah.
There is a drop dot duplicate. Oh, there is
Yes.
lots of functions. Okay.
Yes. This one is different. Yeah. Directly you can use this one. Okay. But if you want to see this one, then yeah, for that this code is there. Okay. So now our shape is around yeah. Since I copied this data, I just created a new copy of this data because I don't want to change anything in the original data set. Okay. So that's why yeah. Otherwise, after trying first time, yeah, I would have got the yeah. You all would have got the 1,337 yeah number of samples. Okay. So this is the new number of samples. Okay. On that day we were talking about this, like how to get that categorical data. Like yeah, I remember in last live session you were only asking about yeah, we have used that one like from this to if it is not in the integer list. Okay.
Yes.
For that, yeah, for that also yeah, here we can use I came up with new terms like yeah, we can use this one also to get the categorical columns data to we will check the data type. Okay. If it is a number, then if it is number, then we can put all those in the numerical columns. Okay. And if it is yeah, here we are just doing in the first one. Yeah, okay, just what we are saying that we are checking that we will select the data type which is as a number. Okay. So that we selected for the num columns, and for the categorical columns what we do it is like we just exclude the number part. Okay. So I think you got this code also works properly.
Yeah, but it gave me the entire columns, right? So okay, it is just a
yeah, that column one is in the categorical column. No, that is what we wanted to know. Okay. Or you want to just this one only, then that is also easy, like that you can write this dot names.
okay.
That way give you the okay, whatever is it's since it's not a data frame object has columns actually, sorry, names is in the names is a parameter and columns is here. Okay. Sex, smoker, and reason that we got.
Yes.
Yeah, like that we can get. So yeah, that's not an issue. Okay. Yeah, like that we can get the columns name like which is
then now if for balancing we have to ensure there is region balance, gender balance, and smoker versus non-smoker.
Yeah. If but yeah, we have to do that. If it is highly imbalanced, like yeah, one is a 90%, 99%, other is a 1%.
There will be, right, smoker. I'm expect that there will be fewer smokers, so we have to get that smoker column. Yeah.
Yeah, we can check the count. We can count the values. We can use this count values. Okay. Here we are seeing this one. Instead of unique, just use the count values. Like how many smokers are there? I think, yeah, there is count values, no? Or count value, what is the? Okay, let me check this one.
Return counts equal to true. That gives you the counts.
Okay, okay, yeah. In this one only, no? In here, you are saying, or here you are saying, which one you are saying?
At least in NP, when you do unique, you can say return count equal to true, something. Yeah, that's one particular
Okay.
part.
Okay, if it will be there, yeah, that will also work. And some other. Like that you were saying, or is it an argument or what?
I have to check. Is it not working? Maybe in NumPy
Yeah.
it works. I don't know whether data frame it is there, so I have to check.
Actually, I wrote it as count values. It is as a value count. So many confusions. Okay. Yeah, now it will work. Yeah, like that you got that. How many no are there? How many yes are there? So yeah. So there are 1064 people who don't smoke, and yeah, 274 people smoke. Okay, like that you can take. That's okay. Count works. Okay, like that you will get. Okay, so we drop that value, and after that, yeah, this is we got as data type. All the numerical columns are here. Okay, so we'll just do the one hot encoding for the categorical variable. You can directly do this on the. No need to do this here. I think, yeah, what is done is, yeah, we just did a one hot encoding for categorical columns, and later we concatenated it. But no need to do that one. You can directly do this one in data frame, in original data frame also. Okay, just for demonstration purpose.
So it's
looks
called
okay.
get dummies. So very
Yeah.
unusual name. I wouldn't have guessed that name in my life.
Okay, for one hot encoding. I think it is. It had been taught in the initial lectures, no? But to do that one hot encoding. Not get
It is
it.
fine, but the name is called
Yeah.
get dummies. I wouldn't have guessed it.
Okay. Yeah. So I think one name is also there, like to directly in SQL, and I think, yeah, that is so that like directly one hot encoding something, some name here like that. Okay, you can check that, because it's already 37. Okay, so yeah, doing that we will just do that one hot encoding, and yeah, we concatenated both columns, numerical columns, and yeah, one hot encoded column. So this is our final final data set where no categorical column is there. All the columns are either all the are numericals only. Okay, so
But,
some yeah.
You have not taken out the expenses, right? Because now it has been on top of expenses, so we shouldn't have. Okay, fine.
Yeah. No,
You can
no,
do it that way also. Okay, yeah.
yeah. At any place, yeah, you can do that. No need to do this one. Yeah, here, as I told you, these things are, yeah, you can do that. So yeah, we just did that. Yeah, we split it into X and Y format, and yeah, we use this trend test split to split our data set. Okay, we take around 75% data for training purpose, and yeah, 25% for test purpose. Okay, so this is the new shape of our data. Like X10 is total 1002 samples we took for training our model, and 335 we kept for test purpose. Okay, so as I told you, like, yeah, we just what we did is here, like we took the number of samples. Okay, so how we took it, like, yeah, data to the shape 0 putting 0 here, we are getting the number of rows actually. Okay, you can just see this one also. Okay, just I think. Okay, let's type only data2.shape 0. Yeah.
Data 2, sir. You put it in the.
Okay. Yeah, so to 1337 a number of samples were there. So what we did is like we just calculated the square root of this term. Okay, this one value we got 36.56. So then we applied this seal. So with it does simpling like it gives the smallest integer value. Like if it is 36.57, then it will give 36 as a result. So yeah, we got as a smallest. Okay, oh, if it is more than more than 36.5, it gives the it gives 37 as a value, like that. I thought, yeah, it gives the smallest value. No, it looks, yeah, it gives the closest value.
Ceiling, no, not floor, right? So ceiling will give the higher one.
Yes. Yeah, closest integer value it is good. So I think, yeah, will be closest. Okay, so yeah, it's just a simple code. Here just we use this for function to we just simply printed the RMSE value for all k, all for different k. Okay, so yeah, that is what, or we can use that grid search part only. Like here I have written that part. Okay, so we just use this min function to check that what is the minimum RMSE value, that is 10,231. Okay, so 10,031 we will get around, yeah, somewhere around k equals to 4. For k equals to 4, we are getting a RMSE value as, yeah, 10,231. Okay, so yeah, we can directly train our model using that one. Okay, like we simply calculate our train here. Okay, we haven't trained our model in that, or we can just create our model like model.fit k near. I mean, just copy these 3 lines. Okay, and simply create our model by just keeping the 4 as this one. Okay, so like that. Yeah, now our model is ready. Yeah, okay, because I have to run all the codes again, so yeah, that's why I'm not doing this. Like that we can get the result. Okay, so yeah, what here just I just did that, like again we created a data frame where we kept that RMC values, and yeah, one new column as error. Okay, like I kept that RMC value and we gave that column name as a error. Okay, so this is our, or we can put one more column also, like k values, and yeah, for that case what is the error we are getting. So, okay, and actually this number of, yeah, this value is also representing, index is also representing the k value if we will add the index value with +1. Okay, so we plotted this curve for that error curve. We see that, yeah, around k equals to 4 we are getting the minimum RMSE values. Yeah, so
even that RMSE is pretty high, no? 10,000 is a pretty high RMSE.
RMC depends on many things, no? Like see,
the expense themselves are in tens of thousands, so you don't want to have the error in tens of thousands.
Yeah, if you will normalize that, then it will be in lesser quantity. Okay, see, if we are,
we didn't put scaling at all. Okay,
yeah, that is the case. Like if it is 5 and 4, then we will get our area square will be 1. Okay, yeah, and if it is around, yeah, 1,000 to 32,000 to, and yeah, you can understand, like if we have lesser values 5, 4, so still there is error is around 10%, but yeah, mean square error we will get as like 1 only. But if the same case will happen with a larger number, so that value will be very high. Okay, so yeah, that is the case. Okay, so yeah, we'll just see that we'll see quickly regression on large scale data. So we created a sample using trend test split. Like yeah, we kept 1 lakh samples and we kept features around 50. Yeah, so we created we got this data. Okay, so in the large scale data, what is our issue? So can you someone explain?
Sorry, what was the question?
What issue we face on large scale data actually?
Large scale data.
Yeah, it is a simple question only. Yeah, I know.
No, basically the amount of memory we need, right, to store all the data and to do the processing.
Yeah, exactly. That is the main issue which we face when we work with the large scale data. Okay, so for that what we do is we process data in chunk. Okay, so one thing is there as we saw also in the class lecture, we use that part. I mean in PD.RSSB we use that chunk parameter. Okay, like that we can do, or some other way we can do like that way, or other way can be we will convert all the data in ND array format. Okay, and then in ND array format we will reshape it. Just see just how we reshaped it. Just see it like we thought we had 1 lakh data, 1 lakh number of samples. Okay, so what we did here is and 1 lakh. I should write it. That's better. Number of training samples equals to 90,000. Okay. So we have now number of samples equal to 90,000. So what we want is make chunk of 100 data. Okay, 100 data we will make as a chunk, like a subset of the samples. Okay, so 100 data we will work on 100 data point at once. Okay, like that we will do. So to do that, how can we reshape our data set? So actually I was not supposed to see that. So that code, yeah, just say like what. Yeah.
This is also a question I had. Now, why use it reshape, right? We are saying resample. We are reshaping the data set.
Yeah, you can say that. What you said, just say again. Hello.
See, we use the word reshape for what we did with the features, right? We reshaped it into a flat one-dimensional array. But in this question, even the greater question, I asked that question in this course also, right? But here we should say we resize it so that it is in 100 samples, right? We are not reshaping it.
Okay, so yeah, but the thing is here we are. You can say that also, yeah. That also, yeah, we can say that.
This is the same format in the graded question also. Graded assignment also uses the same word called reshape.
Yes. I just by seeing this code only, like yeah.
I assume that I have to split it into 100 each, run the loop that many times, right?
Yes, 100 each. Just repeat your last sentence. What you said.
In this case, we are saying 100 samples, right? So I have to run the loop for every 100. I do a partial fit.
Yes, exactly. That is what you have to do. But the thing is, you have to receive. Yeah, in whatever manner you think this one. Yeah, whatever you are thinking. Yeah, that is what we will do. Like yeah, we will create a 100 chunk. We will keep a chunk size as 100, and yeah, we'll loop for that. So to do that, yeah, there can be many ways. As in the first case also we saw, no, like PD.res we put chunk size equal to 100, and yeah, that will work. But the main case is pandas is data frame format is very slow. if we compare it with the NumPy format. Okay. So the reason for that is like every data is associated with their index value. So to access the data, we have to like in the system, it performs like it refers that index value and all. Okay. So every time so due to those things, those things, it gets slower. Okay. So yeah, one more method can be like you can just convert all your data into ND array format. Okay. You can do that. Okay. So to do the
One question, sir.
Yeah.
In the instruction, you say import standard scalar and transform using partial fit, which means even the transformation we do every time, every loop we do the transform, not once.
No, the thing is, you can't do like that. You can't transform your data. As I told you, no.
Yeah, I understand. Yeah, because you're not reading the data, so even that also works, right? So it's a partial fit. So you'll keep reading it again.
But the thing is, see, what standard scalar does is it takes the. You are giving the 100 samples. Okay. So what it will do then? It will calculate the mean of that 100 samples, standard deviation of that 100 sample, and based on that, it will rescale your data. So to use that standard scalar, you have to first partially fit. You have to update your parameter on all the data. Okay, like see here, that is the main. You can say crux of that question. Like you have to train your model using all the data. Okay, with the partial fit, and once you got all the values, all the parameters like mean and standard deviation of all the data. Okay, then just use that to transform your batches.
So this is where it is a bit confusing because if you're reading one by one, how will we do the? See, we can't do this loop, right? The loop again on top.
Again, loop. I'm not getting what you are saying.
The scaling the data, that loop, right? Where you are. See, suppose I have read only 100 samples. Suppose I'm reading it from the file.
Yes.
So I have read only 100 samples.
Yeah.
At a time. So I use fit on that.
Okay.
But not transform, right?
Yeah, not transform. So is there any question, or you just wanted to confirm that?
Yeah, but then I have to run the loop multiple times. So then I read once.
Yes. To do that, you have to run your loop multiple times, because that's why it is difficult to do that standard scalar. At least particularly standard scalar. Okay. So yeah.
Even min max is the same thing, no? So because we don't know what is the min, what is the max, because they keep changing every time.
So, all the scaling part, no, you have to do like that, because you can't do that in that way. So in that question, in the 6, 7, 8 questions is there, no? In that question, these things are only like new trick, you can say. Actually, the thing is, we already have solutions for to work with the large data set, but particularly using sklearn, if we will work with the large scale data, so then to scale that, we have to use these things like that. So did you got my point, or?
Yeah, fine. Yeah, so the way I have to do that. Okay, thanks. Got that.
Yeah. Because I was also checking that we were not getting the correct answer. Yeah, I just checked. I checked using that, and after that, I came up with this solution. Like, first we will train our model. First we will train our scalar part using standard scalar with all the data set, and then later we will transform our data. Like later we will transfer our X batch using that one. Earlier, I was using that just like here only when I was using that transform, no, then we were not getting the correct answers. So that's why, And one more thing, just think like how it would see. This model part is okay. Like you know that how SGD works. So for SGD, it's not an issue. Like when we are putting the data in batches. Okay, for that formula you know. But how it works, like that standard scalar using partial fit, how it works. For that there is a different formula. Like how you calculate mean and standard deviation using partial fit. There is a different formula for that. You can you just Google do Google search, and yeah, I would say this, see that formula. Okay.
Okay.
Yeah.
Understand.
Yeah. So I should you it looks you wanted to ask any other question, so you can ask, or I should move further, or should I move further?
No, I get that point. So just to tell one thing, in the partial fit, I figured it out. I just thought I'll ask the question also. If I'm doing it on a regressor, right?
Yeah.
Not for classification, I don't have to give the labels.
Yeah.
Because if I suppose I use SGDC classifier, the first iteration I have to give the labels. But in regression, looks like I don't have to give any labels.
For regression, you don't want to give the label. So why then? How you will train?
No. Say for example, not the regressor.partial fit. You're just giving the X batch and Y batch. You're not giving the labels. Suppose it's a classifier. In the first call to the regressor, you're supposed to give the class number of classes, the class labels.
Yes. So here no need to do that. Okay. Here why you will get the number of classes? It is not here you what it wants is number of what is all your features, and what is the predicted value for that. What is the accurate value target variable? These two things only,
Yes. Yeah.
It will work. Nothing else is needed in this case. You are just trying to fit. I think I'm not able to get your question actually. So whether you got your answer or
I got the answer because in the demo the sir uses only the classifier.
Yeah.
And all the graded assignment questions are all regression questions.
Yes. So particularly I said that was just I thought sir has already covered that classification part, so I should cover that regression part. At least in any ways you should know that, like you got to know that how classifier model works, and now you got to know that how regressor model works. So if you and I had planned only like I'll teach these two things in that SGD session only, so that you get to know like how you will standardize your data set, and how you will use this SGD regressor. These two lines of code is enough. But some other tricks are also there, so just to be careful while solving the 6, 7, 8 questions. For first, 3, 4, 5th, third, fourth, and fifth question. This is you can say the exact code on this code will work. Okay, so like that. We use this standard scalar to scale our data set, and we transform that. We are transforming our X batch, and then after that we are applying the regressor.partial fit, and like that we will train our model, and then we can check the intercept value. It comes around 0.183. Okay, and we can check all the coefficient value. These are the list of coefficient values. Okay, now we can calculate the mean square error, R2 score using a Z regressor. Okay, so nothing new we are doing. The same code only. This one only. It is just that it may look that it is wrong here. Okay, so here we have calculated without transforming the data set. Okay, so you can write that part. Okay, just main thing is I just wanted to show this part. Okay, just it's okay to remove this one because we already trained our model, so we can put this one. I mean, these two things here also, like after this code. Okay, like that it will work.
Yeah.
Yeah, because now we have to fit our model. Yeah, like after transforming the data, and yeah, after that, yeah, we are predicting it. Okay.
So since we are doing all this, so in the partial fit, there's no way to use pipeline.
Yeah, we can't use that pipeline using the using these two terms. Yeah, right.
Okay.
I had should check this like here I haven't used that scalar for X test. So yeah, you can do that, or else yeah, that thing is okay. Yeah, you should think because the codes are you have the codes, but yeah, you have to think because yeah, it is not in a correct manner. Some at least for the test part. Okay. So yeah, it's just simple logic only. You have to apply some simple logic, nothing extra. Yeah, using that, yeah, you calculated the train like mini square error for test data, and yeah, RT score for test data, and yeah, similarly mini square error and RT score for train data. Okay. Yeah. So we asked one question was there like after the fourth iteration or fifth iteration, what is the value? So it is nothing like yeah, simply just put this code like if I equals 4 and yeah, then break the statement.
Yeah. So
Then
there is
break
no
that.
way to get the. I mean, even last week also there is a graded question about from some particular iteration. Unless we do it ourselves, there is no way to go back and look at interim values, right?
Yeah, we can do that. Like we can create an empty list and yeah, we can see
But
that.
we have to do it ourselves. The methods don't give it.
Yeah. Yeah, with partial fit. Yeah, I don't know any method is there. If it would be, but then I don't know. Yeah. Yeah. Then yeah, using that regressor dot intercept and yeah, regressor coefficient value if I equals to 4. One good thing is there, like yeah, if we'll the same thing if you'll put it's yeah just like a normal coding part.
No, you can just print and then continue, right? So
Yeah, that will also work. That will also work. And yeah, one more thing, yeah, here if you will put it above this one, like if we will put here that thing, then we have to write after fourth iteration. It is if it is after fourth, then we have to put here as I equal 5. So did you got what we did here?
but one thing is that the range, right? The range shape 0, the I range should be divided by the iteration, batch size, right?
One second, just let me. Yeah, so please say what you are saying.
The range for I in range, it can't be shape of 0, right? It should be divided by the batch size.
Would be what do you think this train xtrain.shape will give you?
Number of the full number of samples, but we want to do it 90 samples together, right? Not each sample separately.
90 samples means
Or did okay.
It will give you the simply a number like how many chunk size you have, like how many chunk you made. See, like how I received the data. Maybe you can receive in a different way. Then yeah, using that you have to plan your code like that. See, what we did is like we had 90,000 number of samples and yeah 50 features. So what we did is we kept this as a 50 features only, but we received it in such a manner that now we have 900 samples, 900 chunk, and yeah, in each chunk we have 100 samples. We received it in such a manner. Okay, just see here. I just checked like yeah, the 0 will give the your first dimension. Okay, if we'll put we will write here 1, it will give you the your second dimension. Okay, if we will write 2, yeah, it will give you the third dimension. Okay, so what we are doing here is in this line.
Okay, I get that. So we have done a reshape. Okay.
Yeah. So yeah, it is just iterating through the first chunk. In the first round, it is taking first chunk. In the second round, it will check the second chunk. So our chunk, yeah, we are providing a range as a from 0 to enough number of chunks. So we had 900 chunks. So yeah, from 0th chunk to 900 chunk. For that, it will give the answer. Okay. Like, yeah. So yeah, that is all about the session. Yeah, and yeah, we covered all the part. Yeah, few of the oral questions were there I had kept, but I think yeah, many questions we already discussed in the last session only, like what is SAG full form, like SAG. So what is the main difference between SAG and Saga? Hello.
No, I think it was briefly mentioned. I don't remember that. Yeah.
Okay. Yeah. No, the thing is, yeah, the main issue with the SAG was that we can use only penalty L2 with
L2.
SAG.
Okay.
So yeah, so that's why the Saga is improvisation of this SAG. With that, we can use the L1, L2, elastic norm, all three penalty method. So yeah, that is the main difference, nothing else. So Saga is just improved version of this SAG. Okay. Stochastic average gradient, and yeah, that is some, I don't remember, it is the extra there. Okay, so yeah, if you use the multinomials having solver, then yeah, we can't use this. If we are using multinomial type, then we can't use this solver equals to linear. Okay, and yeah, one more question is like from where does that term Manhattan distance we calculate? No, like do you know like from where that term originated? Like from where that term came from?
Yeah, this is a New York, Manhattan's.
Yeah. So yeah, the thing is, yeah, there the street shape is like a grid type street is there. So that's why this from there only this term came, Manhattan, because to calculate you can search that. Okay. Okay, Manhattan distance. Okay, you can read about this one. Okay, I would say just read about this one, like how we got to know why we call this as a Manhattan distance. Okay, or it is called as a taxi cab geometry also. Okay, you just read about this one. Yeah, that's all about yeah, about the visualization. I think yeah, you will be able to do that yeah, grade 2 part. Okay, you got to know about the yeah, all the data like classification, regression, and all. Yeah. So anything else if anyone wants to know, you can ask. Yeah, hello.
No, I don't have. I'll wait for others to ask their questions.
Yeah,
I think
yeah,
I've been asking quite a few.
Yeah. So hi Gautam. Yeah, hi Anuid. Hi Pranav. Hi Saurav. I think yeah, people are leaving. So yeah, we can. I think yeah, that's all for today's session. Yeah. I think now we'll meet in the 11th week. Yeah. In 11th week, what is the syllabus for 11th week? K-means actually, yeah. There we will work on the recommendation engine, movie recommendation engine. Yeah.
Okay.
Yeah. Okay. Thank you, everyone. Thank you all.
Thank you. Yeah, and one curious question. So the PyForest doesn't seem to work for some methods.
Yes. That's
so we
why,
just have to assume, right? It works for some, but doesn't work for some.
Yeah. Always assume this one only.
Okay.
Yeah. Thank you, Adi. Yeah, like that only. Like it doesn't. It works on just some famous algorithm, some famous yeah, libraries and all.
Okay.
Yeah, like that only.
Thank you.
That's why I told you, like, just to make a set like for which it doesn't work. Like yeah, that would be a lesser in number, or yeah. So we can't rely currently
fully on it, but we should remember that.
Yeah.
Okay. Thank you.
Okay. Thank you all. Yeah.